In this video, we're going to continue with the skills needed to do hydrate analyses. So our next skill that we have to see is how to figure out the mass percent of water in a compound. So let's go ahead and do some practice problems to acquire that skill. So we want to find mass percent of water in hydrates. Essentially, what percent of the compound is water by mass? So there's a few ways you can do it, but if you're given a formula rather than just mass data, you find the molar mass of the entire compound, find the molar mass of water in the compound, including the coefficient of the water. So if there's 7 waters, make sure it's times 7. And then do the molar mass of the water divided by the molar mass of the compound times 100. So it's basically saying water out of the entire compound times 100, where water is like the score on your test, and then the bottom part, the denominator, is like the out of for your test. So let's do this example over here. Find the mass percent of water in magnesium sulfate heptahydrate. And so I won't redo all the steps here, but essentially first you'd have to find the molar mass of the entire hydrate. And the reason I'm not going to redo all the steps here is because we actually already have the molar mass of this hydrate done for us in a previous problem. We had 246.52 grams per mole. We did it in the previous example. So 246.52 grams per mole. Let me just double check that was right. Right there. And the molar mass of water is our second step. But don't forget, it's 7 times the molar mass of water because there's 7 waters there. And we found that that was 126.14 grams per mole. So now that we have the water and the entire hydrate, we can find the mass percent of water. So we can simply do mass percent of water is equal to the molar mass of water in the compound. So molar mass of water in a compound, in other words, 7 times the molar mass of H2O, because there's 7 waters here, over the molar mass of the entire hydrate, times 100%. And so what we're going to do is our 126.14 grams per mole over 246.52 grams per mole. Cancel those out, times 100%. And so we get 126.14 divided by 246.52 times 100. And we get 51.168262221%, or approximately, to the correct number of sig figs, so 5 sig figs here, 51.168% H2O by mass. And keep in mind, this was from molar mass information. We didn't have any mass data provided to us, but if you had mass data provided to you, then you could just do the mass of the water given over the mass of the hydrate, and then that would give times 100. Very similar to what we did for percent composition in the previous lessons in this unit. So let's take a look at the mass percent of water in CuSO4 5H2O, so copper 2 sulfate pentahydrate. Same process, except in this case we're dealing with a different compound. Once again, I'm not going to redo the whole thing because we actually have this one provided to us already. We did the molar mass of that hydrate in a previous question in this handout. And so if we go up, the mass of the copper 2 sulfate pentahydrate, which we did here, the molar mass of it's 249.72 grams per mole. So we have 249.72 grams per mole. The molar mass of water, so 5 times the molar mass of water, because there's 5 waters in it, is 5 times 18.02, which is 90.10 grams per mole. So 90.10 grams per mole. And then now we can do our third step, which is the mass percent of water is going to be 5 times the molar mass of water, because there's 5 waters in this compound, divided by the molar mass of the entire hydrate, times 100%. And so we get 90.10 grams per mole over 249.72 grams per mole. Cancel the grams per mole out because you have it on the numerator and denominator, times 100%. And so let's go ahead and do that. 90.10 divided by 249.72 times 100. And we get 36.08041,006%, or approximately, to 4 sig figs, 36.08% water by mass, H2O by mass. And that's our mass percent of water in the hydrate. So again, these are 2 examples where we didn't have mass data, but we had the formulas and we could use the molar masses, because the law of definite proportion still applies to hydrates. So let's do an example where we need to step it up a bit with some mass data provided. Here we have a compound given to us, which is Na2S2O3.5H2O, so it's a pentahydrate. And there's 2 parts to this question. We want to find the percentage of water in this compound. And then we're going to tell you that, let's say you had a sample of this compound, you had 215 grams. Based on your percentage you calculated in part A, how many grams of water would you have in 215 grams? So let's go ahead and figure that out. So firstly, we'll do part A. And you can try this yourself too, to see if you're on the right track and compare answers after. We want to find the molar mass of the entire compound, Na2S2O3.5H2O. And so I'm going to do that in my calculator quickly, but I have 2 sodiums, so 22.99 times 2, plus 2 sulfurs, so 2 times 32.07, plus 3 oxygens, so 3 times 16. So I get 158.12 grams per mole. That's my ionic compound part, plus the 5 waters. So 5 times 18.02 gives me 90.10 grams per mole. I add those 2 up, 158.12 plus the 90.10, and I get 248.22 grams per mole. So that's my first step, finding that molar mass of the entire compound. Step 2 is finding the molar mass of, the water and multiplying it by 5, which we already kind of did in step 1. So let me rewrite that so you can see what I wrote there. 5 times the molar mass of H2O is simply the 90.10 grams per mole. And our step 3 is to find the mass percent of water by doing the molar mass of water times 5, which is the 90.10 grams per mole, divided by the entire molar mass of the compound, the 248.22 grams per mole, times 100%, and we get, 90.10 divided by that entire molar mass times 100, 36.298 44493%, or if I want to leave it to 4 sig figs, it looks like it would round up there, so 36.30% H2O by mass. So that is our mass percent of water specifically in the compound. Now we just need to do part B. So part A was in blue over here. Part B, we'll do it in a different color. Let's do it in green. So we know the percentage of water in the compound, which is that 36.30. All we really need to do is multiply a percentage by the total mass of the sample provided. So it's almost like saying if you got 36% on a test that was out of 100 marks, you'd do 0.36 times 100, and you get 36 marks. Or 0.36 if it was out of 50 times 50. So here, to find the mass of water, we're going to do the mass percent of water times the mass of the compound, of the sample, which is 215 grams here. So that's the actual sample that we're measuring in the lab. Don't forget this mass percent needs to be divided by 100 in this decimal form. I use my unrounded value. So I'm going to get the 0.362984443. That's 36% just in its percent in its fraction form, decimal form, times the 215 grams. So times 215, I get 78.0416 5659 grams, which is approximately, if I want to keep it to 3 sig figs, 78.0 grams. So we can say therefore there are 78.0 grams of H2O in the 215 gram sample. And I should say there are approximately, because we rounded there, and we're acknowledging that there could be some errors in our sig fig areas. So that's the last skill you need to know before you can jump and do hydrate style questions. So again, to recap, we saw how to write dehydration equations. We saw how to figure out molar masses of hydrates. Using the molar masses of hydrates, we saw how to determine the percent composition of hydrates based on just the water and the ionics. If you want to, you can go further and you could say how much percent is hydrogen, oxygen, but we didn't. We just focused specifically on the water versus the ionic compound. And then we saw how to figure out, use our percent data to figure out the mass of water in a particular compound or a particular sample of a compound as well, using some mass data and molar mass data as well. In our next video, we're going to take a look at this type of experiment where you basically remove water from your hydrate and you use the data provided to figure out what the formula of your hydrate was. So you may not know what the X value is over here, but we're going to figure out what that X value using an experimental procedure where we dehydrate a hydrate. And we'll do a few sample problems with that coming up in the next video.